Hello, I'm Patrick McMullen, Director of Computational Toxicology at ScitoVation. I'd like to tell you about how we're using toxicogenomics and other high-throughput molecular technologies to help our stakeholders make more efficient chemical safety decisions. At ScitoVation, we specialize in the development and implementation of new approach methodologies, or NAMs, to provide alternative data streams to classical animal testing. As you know, toxicology has historically made use of animal studies to predict health outcomes in humans resulting from chemical exposures. These experiments are expensive and time-consuming, require a lot of animals, and are not necessarily predictive of human health outcomes. As such, ScitoVation advocates for the use of a tiered approach to chemical safety testing that uses higher throughput, inexpensive methods to inform the need for and design of downstream testing. We use transcriptomics technologies across the middle tiers of this approach to maximize our understanding of toxicology with test systems using simple cell culture models, more complex organotypic models, and short-term in vivo experiments. Liver hypertrophy, post-implantation loss, tumor formation, and other apical effects can be traced back to molecular changes at the cellular level. This is the basis of etiological frameworks such as the adverse outcome pathway. Toxicogenomics takes advantage of this relationship by probing molecular changes to identify perturbations that relate to apical effects. This relationship between apical effects and molecular perturbations allows us to use transcriptomics to determine compound bioactivity. Indeed, an increasing body of evidence, including work done by the National Toxicology Program, has indicated a quantitative relationship between transcriptomic points of departure and effects observed in traditional animal studies. We use toxicogenomics to help our stakeholders estimate toxicity liability across related chemistries. This approach adds value to our clients' lead selection and alternatives assessment processes by providing a lens into toxicity without the need to execute an in-life study. We are also using toxicogenomics as the foundation of a biologically based read-across. As you may well know, conventional read-across predicts target chemical toxicity based on structural similarity, effectively extrapolating what we know about data-rich chemistries onto unknown but related compounds. In addition to structural and physicochemical features, we use transcriptomic profiling to establish that compounds that look similar also act similar in a biological context. This provides an additional layer of information to the read-across argument, one that we argue is closer in its relationship to the apical effect than structure alone. In addition to filling data gaps via read-across, there are opportunities for this approach to help establish scientifically grounded chemical groupings for category approaches. As we have pioneered these applications of toxicogenomics, ScitoVation scientists have also developed new techniques to visualize and communicate the complicated data that emerge from omics technologies. For example, summarizing toxicogenomics profiles using biological pathway information and projecting the relevant pathways into visual space according to their relationships, this is a process we call MOAVIS, allows chemical safety stakeholders to interact with their data in a more intuitive way. As toxicogenomics and other complicated data streams become more commonplace, one way we at ScitoVation see our role evolving is in making information accessible so it can be used more effectively by toxicology experts. Toxicogenomics is one of the many NAMs that have us excited about the direction toxicology is pointed right now. Combining NAMs into a tiered workflow provides high-fidelity information about hazard in an efficient manner. Chemistries of low concern can be identified without executing conventional in-life studies. ScitoVation helps chemical safety stakeholders realize the vision of toxicity testing in the 21st century. If you'd like to learn more, we invite you to visit our website, connect with us on LinkedIn, or email us at customerservice@scitovation.com. Thank you.